Hi, this instructional video is about binomial theorem. Binomial theorem. What is that? During your Algebra 1 studies, you learned how to take a square of a simple binomial and expanded it. And the way we expanded it back in Algebra 1 was by the FOIL method. Since it's a square of this binomial, you write it twice. And basically it's a distributive property. The first term to the first one, which is x squared. And then the last term to the last term of the second one, which is 1 times 1 is 1. And then the sum of the two products, 1x and 1x, which is plus 2x. Okay? So that was expanding it. And that's when the exponent was a 2. So in binomial theorem, we're going to deal with when it's 4, or even more than that. It can be quite tedious, having to do this over and over with 3 or 4 or 5 or 10 different binomials. So we come out with the general form of a binomial theorem, which is given as a plus b to any exponent nth power, the combination of the total number of exponent, choose starting with a 0, and then we go a gets the most exponent, and the second term b gets none. And we're going to add to that the second combination where the exponent chooses 1, and the a gets now whatever that exponent top was, reduce it by 1, and we give that to the second term b. Plus, and we're going to continue this on cycle by n to the 2. And so this time, instead of reducing it by 1, we're going to reduce it by 2. And we're going to increase the second term b by 2. I'm going to continue that on until we get to the combination of n choose the last term n. And the a, we're going to say n minus the n, but that's going to become a 0. And any exponent to a 0 is going to simply become a 1. And the second term b gets the topmost term nth. So if we use a summation notation to represent this binomial theorem, we say the sum of, where the lower limit is, the r is equal to 0 all the way to that nth term, and the combination of n choose the r of a of n minus dr times the b to dr. So we're going to use this general form. So let's see this in action, huh? So here we have x plus 1, same as before. But instead of a square, it's a fourth. So let's break this up. So we're going to say that this is equal to the combination of the topmost exponent 4, choose 0. And the first term x, we're going to give it the fourth exponent. And the second one times 1 to 0. See, just like that. Plus, and we're going to do this again, but this time combination of 4 choose 1 this time. And the exponent for the x becomes reduced by 1, and that becomes increased to the second term, 1. And we're going to continue this on until we get to the last term. So c to the combination of 4 choose 2, x to the 2 reduced by 1 again, and 1 to the increase by 1, plus combination of 4 choose 3 this time. We're almost there already. X to reduce that by 1 again is 1, 1 to the third. And this will be the last one because it's the last term, 4 choose 4, which will become a 1. Times x to the 0, reduce that 1 by 1 is a 0. And 1 to the 4th power. And we're going to start evaluating. The combination of 4 choose 0 is simply 1. X to the 4th. Any base that raised to a 0 power is simply 1. Plus 4 choose 1, that's a 4. X to the 3rd. And 1 to the 1 power is simply 1. Plus 4 choose 2. Well, let's do a quick arithmetic here. 4 factorial minus 4 minus 2 factorial times 2 factorial. That's 4, 3, 2, 1 over 4 minus 2 is 2 times 1 times another 2 times 1. Those are gone. That one reduces that by 2, so it's a 6. So combination of 4 choose 2 is 6 x squared, and 1 squared is still 1. 4 choose 3 is just like 4 choose 1. So it's simply 4. x to the first power times 1 to the third power is still 1. And plus 4 choose 4 is just one possible way of doing that, so it's 1. Any base raised to a 0 is a 1. And 1 to the fourth is still 1. So put it all together, 1 times x to the 4 times 1 is x to the fourth, plus 4x to the third, plus 6x to the second, plus 4x, plus the 1. So this is the expanded form of x plus 1 to the fourth power. Not too bad. This may look long, but it's actually faster than having to do the distributive property for each of the binomial. In this case, there are 4 of them. Can you imagine if there's like more than 10? Whew! So if you got the idea of this one, you try the next one. These two. And just to warn you, that little exponent 7, it makes it really spicy. So let me draw a little chili pepper to warn you. Right there. Try those. Oh, and here's the general form of the binomial theorem. How'd that go? Kind of spicy, huh? So you said, okay, so the combination of the most higher exponent 4, choose starting with a 0. And the first term, give that the fourth exponent. Plus, this time we have a term that has coefficient as well, so we're going to put there in parentheses 3y. Oops, that's not a plus, not yet, it's a times, to the 0 power. Now we say plus. Now combination of 4, choose 1. Reduce that exponent 4 by 1, so x to the third power. Now we're going to give that term 3y, raise it by 1. And we're going to add to that the next sequence, combination of 4, choose 2. Reduce the third power by 1, so it's now 2. Increase that second term by 1, so it's going to be 3y to the second power. Remember the rules of exponent? Keep that in mind. And then combination of 4, choose 3. X to the 1 now, reduce that by 1. And 3y, increase that by 1, so it's going to become 3. And finally, the last one is combination of 4, choose 4. X to the 0 power, I just follow it through all the way, so I don't get lost. And 3y raised to the last one, which is the fourth power. Now I'm going to start evaluating. 4 choose 0, there's only one possible way, which is 1. Times x to the fourth, any base, even with the coefficient, raised to a 0, still 1. Combination of 4 choose 1 is simply 4 times x to the third. And the rules of exponent says take that 1, give it to the 3 and the y, so it's still 3y. And we're going to rearrange that a little later. 4 choose 2. We did that before. We said that was a what, 6? X squared. And now the rules of exponent kicks in. That's 3 squared, which is 9. And y squared. 4 choose 3. That's back to being 4 again. X to the first power, so it's just x. And 3 goes to the 3 and the y. So that's going to be 3, 3, 3, which is 27. Y to the third. And combination of 4 choose 4, there's only one way of doing that. Any base raised to a 0 is still 1. And now 3y to the fourth. 4 goes to the 3 and the y, so that's 81. Y to the fourth. Let's clean it all up, and we will have our expanded form of this binomial. So 1 times x, 4 times 1 is x to the fourth. Plus, the coefficient 4 and 3 becomes 12 x third y. Plus, coefficient 6 and 9 is going to be 54. X squared y squared. The coefficient 4 and 27, what is that? 108. X to the y third. And finally, 81 is 81. Y to the fourth. Whoo-wee. That would have been like pulling teeth. And finally, the spicy one. Why was this spicy? Because it was a minus, and you have to be very careful. The first and the second problem we did, they were both the sum of two binomials. But now we have a difference. So let's work that one out. Now, I'll go real slowly here. Okay. To work this one out, you say, the combination of 7, choose 0. And we're going to say the first term, 2x, gets the full 7 times negative y squared gets nothing. Plus, combination of 7, choose 1. And then the 2x, exponent 7 gets reduced to a 6, while negative y squared gets a 1. Plus, combination of 7, choose 2. So we get 2x raised to a 5th, and the second term, negative y squared, gets 2. Plus, combination of 7, choose 3 is 2x to the 4th reduced, but the second term, negative y squared, gets increased by 3. Plus, let's come over here. We're running out of space. Combination of 7, choose 4. So the first term, 2x, gets reduced by again to the 3rd, while the second term, negative y squared, gets increased to the 4th. Plus, combination of 7, choose 5. The first term, 2x, gets reduced to a 2, while the second term, negative y squared, gets increased again to the 5. Plus, combination of 7, choose 6. We're almost there. Where the first term, 2x, gets reduced by 1 again to a 1, times negative y squared raised to a 6 now. And I believe this is the last one. Combination of 7, choose 7. Where the first term, 2x, gets nothing, times negative y squared gets to the max, 7. Let's start evaluating. And I'm going to need my calculator this time. Okay, so that equals 7, choose 0. There's only one way, so that's 1 times 2. Okay, 7 goes to the 2 and the x. 2 to the 7th power is going to be 128. So 128 x to the 7th. Any base raised to a 0 is a 1. So that takes care of the first term. Let me cross it off. Whew, so I don't get confused. Plus, 7, choose 1. Well, there's 7 only ways of doing that. 2 to the 6th, that's 2, 2, 2, 8. 8 times 8 is 64. So 64 x to the 6th. Now we're on the board finally. So we got negative y squared. Plus, let me cross that off so I don't get confused. Should you do that during the test? I think that would be a good idea so you don't get lost. 7, choose 2. I'm going to start using the calculator now. Let's go 7, choose 2 combination. That's going to be 21. Okay, and 2 to the 5th. What is that? 32 maybe? 2 to the 5th. Oops. 2 to the 5th. 32. So that's 32. X to the 5th. And negative y squared to an even number exponent is going to make it positive. So it's going to be just y to the 4th. Rules of exponent, remember? Now let's cross that one off as well. Plus, 7, choose 3. Combination of 7, choose 3. That's going to be 35. And 2 to the 4th is 2 and 2, 16, I guess, huh? X to the 4th. And even odd number exponent, so it's going to still be a negative. So negative y to the 6th. Let's come over here and continue. Cross that one off. Plus, 7, choose 4. Are we changing directions yet? Oh, we just tapered off now. That's 35. And then 2 to the 3rd power is 8. X to the 3rd. Even number exponent says that's going to become a positive now. So y to the 8. So 7, choose 5 is going to go backwards from 35. So is that going to be what? 21? I mean, yeah, 21. Let's see. 7, choose 5. 21. And I have to cross this off. So that's going to be 21. 2 to the 2nd power is 4. X squared. And now it's a odd number exponent. So that's going to still be a negative. And y to the 10th. Cross that off. Plus 7, choose 6. So what is that going to be now? 7? 7, choose 6? I believe so. 7. Okay, we're going backwards. Okay. So, and 2 to the 2x to the 1st is just 2x. And it's an even number exponent again, so negative y squared becomes a positive y to the 12. And finally, 7 choose 7 combination is just 1. Any base to a 0 power is still 1. And negative y squared to an odd number exponent is going to still become negative y, and then multiply the exponent to become 14. Let's clean it all up for our final answer. The first term, 128x7 times 1 is 128 x to the 7th power plus 7 times 64, the coefficient. Let me do that so I don't make a mistake. 7 times 64, that's going to be 448. Oh, look, and there's a negative, right? So that's going to be a minus x6y squared plus 21 and 32 multiplied. That gives me 672. And it's a positive x5 y4. The next one is a negative. So 35 times 16 coefficient, that's going to become 560. So 560 x4 y6. And the negative coefficient went over to the front of the term right there. Plus, let me put that over here where I have space, 35 times 8. My calculator says 280. So 280 x3 y8, and it's a positive. And that's going to be a minus coefficient over here on the next term, so it's minus 21 times 4 is 84 x squared y10. And I could do this one without a calculator. Okay, and it's an even number exponent for the second term, so it's plus 14 x y to the 12. And finally, the last term has a minus, so it's negative 1 y to the 14. All right. Dig that, huh? That was painful. I hope you only get no more than one of those questions on a test. All right, good luck with the binomial theorem.